Hello everyone, I'm glad to share my poster to you, which is about my PhD research, targeted protein organization in cells. My name is Bowen Ma, and my supervisor is Professor Wai-Lung. Okay, let's start with the brief introduction about organoid glycosylation. Organoid is a reversible protein post-translational modification catalyzed by a single pair of enzymes, OGT and OGA. It has been found that dysregulated protein organization is linked to human diseases. And here we present a chemogenetic approach, namely OGTAG, to achieve targeted protein organization in cells. This schematic diagram shows the overview of OGTAG strategy. The OGT or truncated OGT fused with FKBP12 F36V mutant form was used as an enzyme for induction of organization. And two kinds of OGTAGs are shown here, which are OGTAG1 and OGTAG4. OGTAG1 is used for induction of halotag fused proteins, while OGTAG4 is specifically used for BRD4. And both of them can be used to induce targeted specific organization. And on the right hand side is a comparison between my method and existing methods for targeted protein organization. Honestly, methods have their own strengths and weaknesses, but I think my method highlights outstanding utility of fast and reversible control. Now, I will introduce the details of my results. Firstly, OGTAG1 and OGTAG4 rapidly induce BRD4 organization. In Figure 3, I show the chemical structures of OGTAGs, which including OGTAG123 as a general OGTAGs and OGTAG4 for BRD4 specifically. And in Figure 4, I show the time-dependent effects of OGTAG1 and OGTAG4 on BRD4 organization. And we can see clearly, after 2 hours, OGTAG1 and OGTAG4 both induce significantly increase of BRD4 organization. Secondly, as OGTAG1 was designed for general application to all halotag fused POIs, we also apply it to CQ2 alpha and EZH2. Another two proteins also show that OGTAG1 can successfully induce organization. Thirdly, we use site-directed mutagenesis study to confirm the OGTAG1 and 4 induced organization sites are physiologically relevant on BRD4 protein. As can be seen in Figure 6, after site mutation, the organization signal was disappeared. Last but not least, we proved the utility of OGTAG system using OGTAG4 as an example. Firstly, we constructed 0 TPR truncated version of FOGT, which further enhanced the target specificity of our method. Then we conducted a washout study. In this study, we wash out the OGTAG treatment after 4 hours. And also, we set another group which we added AP1867, which is a competitor for OGTAG4, binding to the 0 TPR FOGT. After computation, we can see clearly after 2 hours, the ternary complex between 0TFOGT and the HTN BRD4 was potently disrupted. And after 6 hours, we can see the organization level of BRD4 reduced to the original state. Finally, for the future perspective, we will use OGTAGs to study the functions of BRD4 organization. Also, we will apply OGTAG1 to the study of functions of organized transcription factors, for example, the p53. Finally, we will develop molecular glue type of OGTAG for application in native biological system in the future. At last, we want to thank the funding support from CUHK and Cultural Foundation, and also CUHK Direct Grant. We are also glad for any possible cooperation, and if you're interested in our research, please contact us for plasmids and probes.
Thank you for your listening.